Going multi-region is one of the most expensive architectural decisions you'll make in Azure, and most teams make it for the wrong reasons. Before you replicate anything, you need to answer one question. Are you protecting against a regional outage or just chasing a number in a slide deck? In the next few minutes, I'll walk you through the criteria that actually decide your design, the realistic options for compute, data, and traffic routing, and a framework for choosing active-passive versus active-active. The goal is resilience you can afford and actually operate, not a diagram that looks good but has never survived a real failover. The two numbers that drive every decision are recovery time objective, RTO, how long you can be down, and recovery point objective, RPO, how much data you can afford to lose. If your business tolerates a few hours of downtime and a few minutes of data loss, a warm standby is plenty. If you need near zero downtime and zero data loss, you're committing to active-active with synchronous data paths, and the cost roughly doubles. Don't pick a topology first. Pick your RTO and RPO with the business, then let those numbers eliminate options. A vague answer of just make it always up usually means nobody has priced what that costs. Compute is easy to duplicate. Data is where multi-region gets painful. Azure SQL offers active geo-replication and auto-failover groups with asynchronous replication, so expect an RPO of around 5 seconds, not 0. Cosmos DB can do multi-region writes with tunable consistency, which is the closest you'll get to true active-active, but you must handle conflict resolution. Storage gives you geo-redundant options, but read-access geo-redundant storage is eventually consistent, and failover is not instant. The key rule of thumb, your overall RPO is dictated by your slowest, least consistent data store. Design the data tier first because it constrains everything above it. To send users to a healthy region, you have two main front doors. Azure Front Door is a Layer 7 global load balancer with Anycast, TLS termination, and a built-in web application firewall. Use it for HTTP and HTTPS workloads that want fast failover and edge caching. Traffic Manager works at the DNS layer, so it routes any protocol, but failover is bounded by DNS time to live, often tens of seconds to minutes, while clients hold cached records. Rule of thumb, web traffic goes to front door, non-HTTP or whole stack routing goes to Traffic Manager, and some architectures layer both. Active-passive, also called warm standby, keeps your secondary regions scaled down or idle, with data replicating continuously. You pay far less because you're not running full capacity twice, and the design is simpler to reason about. The trade-off is failover time. You may need to scale up compute, repoint connection strings, and promote the database, which realistically lands your RTO in the minutes to tens of minutes range. This fits the majority of business applications, internal line of business systems, and anything where an hour of recovery is acceptable. It's my default recommendation unless a hard requirement forces otherwise, because it's cheaper to run and far easier to test. Active-active runs full production capacity in 2 or more regions simultaneously, serving live traffic from all of them. You get the lowest RTO, often seconds, and you exercise both regions constantly, so failover isn't a scary untested event. But the cost is real. You're paying for double capacity, and you must solve multi-region writes, data conflicts, session affinity, and idempotency in your application code. Reserve this for systems where downtime is directly and severely expensive, payment platforms, large-scale consumer services, or regulated workloads with strict availability mandates. If your team can't articulate the conflict resolution strategy, you're not ready for active-active yet. 2 hidden costs sink multi-region projects. First, cross-region data egress, replicating large volumes between regions, has real bandwidth charges that grow with your data, so model it before you commit. Second, operational burden. A failover plan you've never run is a hope, not a strategy. Schedule regular failover drills, ideally automated game days, and verify your RTO empirically. Also pair regions sensibly, using Azure paired regions where available, so platform updates and recovery are sequenced for you. And because pricing, region pairings, and service capabilities shift, always confirm the current numbers in the Azure documentation before you finalize the design. Here's the framework. Start by agreeing RTO and RPO with the business, because those numbers eliminate most options. Design the data tier first since it caps the resilience the whole system can achieve. Choose active-passive by default for cost and simplicity, and only step up to active-active when downtime is genuinely, severely expensive and your team can handle multi-region writes. Route web traffic through front door, other protocols through traffic manager. Your one concrete takeaway: don't declare a multi-region design done until you've performed a real failover and measured the actual recovery time against your target. An untested plan is a liability, not resilience. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.